The next presenter is Dr. Jakobus Groenewald.
Thank you. Hello everyone, thanks for the opportunity to just share a little bit about the work I'm doing. My name is Jakobus Groenewald, you can call me Jakes, and I'm a research fellow at the University of Warwick, working for the department Warwick Manufacturing Group. So today I'm just going to talk a little about the project I'm working on, FAPESP, that's really about remanufacturing of electric vehicle batteries. So just a little bit about me, my education. I studied my undergrad studies was doing an electronic engineering degree. I started in South Africa, but I actually finished my degree in the UK, and then was then offered the opportunity to do a PhD in optical communications. My main research areas currently is vehicle electrification and energy storage, looking at applying circular economies to principles to the electric vehicle reverse logistics and battery testing and characterization. Just to put a little bit perspective to where I work at the University of Warwick, and one of the departments there is a multidisciplinary department called Warwick Manufacturing Group, which focus heavily on trying to engage with industry and research. It's also a catapult center, like was mentioned in some of the previous presentations. So it's a host for a catapult center, one of the numerous catapult centers around the UK for high-value manufacturing. So some of the UK education and research and development centres we have is the International Manufacturing Centre, International Digital Library, and a few others, an Energy Innovation Centre where I'm involved in. And there's currently being built a new building, will be the National Automotive Innovation Centre, where a multitude of companies will have representation there for automotive design engineering, looking at propulsion systems and so forth. So there's quite a few research groups at WMG. If there's any that you see that you might want to engage with, you're welcome to contact me. I'll put you in contact with the right people. I specifically sit in the energy and electrical systems side. So and we cover everything from design, materials, manufacturing and systems to business transformation. Some of the facilities we have at WMG, this is where I'm quite involved. This is the battery testing and characterization abuse labs. So we can test batteries, we can see how safe they are, we try to set them on fire and see how they perform and that kind of thing. And we have quite a good facility there in terms of being able to test on cell level, on pack level, on module level for electric vehicle batteries or any other kind of energy storage. We also have a battery scale-up line where you can have design and build small scale batches of batteries and test them and characterize them. So that's also a very nice facility we have. We also have a vehicle energy facility where we can test hybrid car propulsion systems, and we're currently just launching a drive simulator where we can test autonomous sensors and driver scenarios. So my main area of research, as I mentioned, is the FAPESP project. So it's to provide information and guidance with decision making about the in-service life extension through repair or remanufacturing of electric vehicle batteries. So we want to look at the feasibility and environmental sustainability of these batteries when they reach end of life. It's maybe worth mentioning that a EV battery at the end of its life there's roughly still about 70 to 80% capacity left in it. So there's quite a lot of inherent value. So we are trying to see how we can capture that inherent value by looking at the reverse logistics and looking at the stakeholders and trying to identify where they could potentially make some money out of this. There's a lot of other projects that's looking into second life applications or energy storage, but we decided we want to focus on keeping it within the same application and trying to extend the in-service life. Some of the motivations behind it obviously is you can reduce your environmental impact through things like manufacturing. The EU has seen a big growth recently in the EV market, so these batteries are going to be flooding the market already flooding the market. There's also the legislative aspects. There's a EU-wide legislation in terms of the battery legislation and end-of-life vehicles legislation, and also it's quite it's quite costly to dispose of these batteries, and there's and because of the legislation, there's some responsibility on the producer to actually pay for the recycling of these batteries. So some of the main research areas that we identify we want to look at in this project is benchmarking the remanufacturing best practice, looking at the safety in the supply chain, testing and data, where I'm focusing on logistics, economics, ownership, and IP. So there's just a few pictures of. So one of the activities in the project is to see how these batteries, how easy remanufacturable they are. So we tried to get a few different mainstream manufacturer batteries and dismantle them and try to assess them with some metrics to see how easy it is and how easy it will be in the future to remanufacture batteries that they currently put on the market, and how much they consider some of the circular economy principles that we want them to consider. It was quite nerve-wracking doing the first one is high voltage batteries, so you need to be careful you don't drop tools in and get sparks and arc flashes and not burn off your face. So but it's fun. It's like it feels like working for bomb disposal. So some of my publications most of it's still related to my PhD work. I've only been at Warwick for a year. I will be presenting some of the work that we've done in this project at the SAE World Conference next month in America, and it's about in-service battery life extension through feasible remanufacturing. I'm also planning to do I'm working on a few other papers for this year. One to do with investigating lithium-ion capacity testing, also impedance testing in some of the batteries, and the other one's a review of the legislation that could affect the reverse logistics of these EV batteries. And so in terms of research projects, as I mentioned, I'm currently working on an Innovate UK-funded project called Abacus, and I've also applied for funding to look into how we can safely, because one of the things that came out of this project that's kind of a sideline is the current best practice to make these batteries safe when they're not safe anymore. For example, when an EV batteries in EV cars in a crash is not very sustainable. They usually would put it in a salt bath to try to discharge it, and you end up with lots of nasty gases. So we want to try to find a better way to make these batteries safe before we can actually work on them in the case where they are damaged. So some of the teaching responsibilities, I will be teaching, I haven't taught yet, but I will be teaching some of the end-of-life and second-life aspects of a TAS module, which is a technical accreditation scheme program that's modules that's being run across a few universities, and it's the new energy storage and high voltage for hybrids and electric vehicle applications module, and I'll be sharing some of my knowledge that we already have learned in this new project. So it's quite a good way to get new knowledge out quick in terms of teaching. And one of my colleagues, Anthony Allen, has also asked me to just mention a new sustainable automotive engineering MSc that they're launching in response to what they see the industry wants and needs. So if you want any more information about that, I brought some brochures about the teaching, and if you have any questions or in terms of collaborations, I can put you in touch with the right people there. So industry collaboration on the current project is JLR, Jaguar Land Rover, as everybody knows, GMP Batteries, which is one of the biggest recyclers of batteries in the UK, and Potenza Performance. And some of the future collaborations, we're working with some of the companies to see if we can get some future collaborations in terms of electric vehicle batteries and some of the aspects that they want to know about this, as Air Liquide and EcoBat and Good Wolf Energy. In terms of they sometimes have problems with testing of their battery packs. So yeah, that's all I had to say. I just want to thank everybody here for their time, and thank you for the organisers, and thank you for FAPESP and the British Council for this amazing workshop and an opportunity to share some knowledge. And if there's anything else, or if anyone thinks there might be a possible collaboration that could happen from this, please feel free to contact me just after this. Thank you very much.